Let's revisit the table from example 5.2.1 here in example 5.3.2. We're going to find the expected value of the number of times a newborn baby's crying wakes its mother after midnight. So the expected value is the expected number of times per week a newborn baby's crying wakes its mother after midnight. Calculate the standard deviation of the variable as well. Understanding that the book goes through the by hand way to calculate the mean and the standard deviation, I'm going to try to show you using technology. Okay, so the two things that we need to know is, first up, expected value, which is sometimes denoted as E of x, is also the mean for our probability distribution function. And the mean is calculated a little bit differently for the table. We don't have data values that we can add up and then divide by how many we have. That's the old way of calculating the mean when we have a full-on data set. Here we don't have a data set. We almost have a frequency distribution, a relative frequency distribution in a way, with these probabilities. So our mean calculation changes, and it really turns into the sum of our x value times its corresponding probability. So in calculating the mean for our set, for our probability distribution table, we'll take the x value times the p of x value and multiply them. So I know this part is in your book, x times p of x, but just starting it out, 0 times 2/50 is 0, 1 times 11/50 is 11/50, and so forth. 2 times 23/50 would be 46/50, and you can keep going on and on. But instead of doing this, punching it out one at a time by hand, let's use technology. So here I have pulled up my Google Sheet, and I need to enter my data. I always like labeling my table so that I know what I'm doing. So I've got my x values from 0 to 5. I'm just going to make it a tiny bit neater here. Ooh, not that neat. Give you a little bit more room there. And then our probabilities here. I know the book has them entered as fractions. That may be difficult for Google to display, and I don't want to sit here and try to figure out how to display fractions. So instead, I am just going to force Google to calculate the equivalent decimal number. Okay, so you see that I have in here equals 2 over 50. Let me show you what happens if I just put 2 over 50. It leaves it as 2 over 50, but I'm not really sure. I'm going to test this out in front of you guys because I'm not sure if Google... Yeah, that's what I thought. So when you enter 2 divided by 50 like this is, Google's not seeing this as a number. And I'm pretty confident Excel does the same thing. They're reading this as text. And text in a computer is formatted differently than a number is. So it won't interact with it in the same way. So Google complains, expects 2 number values. 2 over 50 is a text, cannot be coerced to a number. Okay, fine. Then I want you, Google, to calculate what 2 divided by 50 is. And there we go, 0.04, that's what we wanted. So we're going to do that for all of the values given in our probability distribution. If they're given to us as fractions, we're going to convert them to decimals. And notice all I'm doing is putting an equal sign in the front to force Google to calculate it. So for x equals 2, I have 23 over 50. X is 3, I have 9 over 50. X is 4, I have 4 over 50. And x is 5, I have 1 over 50. I'm going to do a super quick check right here with my values. Sure enough, my probabilities equal 1. That's what I want. I want to make sure my probability equals 1 and that all of my probabilities are between 0 and 1, and I can see that they are. I have no negative numbers. I have no probabilities greater than 1 listed. Now, to calculate expected value, we're going to do x times p of x. And I'm going to center this as well. So I'm just coming over here and grabbing my center justify on the margins so that it makes it look a little neater. And I'm going to make Excel or Google, I'm going to make them calculate it for us. Even though I'm using Google, the steps that I'm using will be exactly the same in Excel. So here we go. I want x times p of x. Hit enter. Let's make these a little bit bigger. Why am I doing it so small? I don't know. I don't know why I'm trying to calculate these so small. Let's make them bigger so we can see them. So equals, I want x times p of x. Hit enter. And I can keep doing this for each one, but you've seen these in other videos. If we grab this little handle right here, notice my mouse changes from a pointer to a solid black plus. I can grab that handle and I can pull it down on the rest of the values and it will automatically multiply x times p of x in those other rows. And we can do a super quick little check here. In your book, it shows that 2 times 23/50 is 0.92. I'm sorry, 2 times 23/50 is 46/50. So we can check, sure enough, what's in the book and what we just calculated matches. Now, for expected value, e of x, or mu, our mean, we would add this column. So if we add this column, we get 2.1. 2.1 is our expected value. Doing a quick switch over here. So when we added x times p of x, our expected value or our mean is 2.1. And that 2.1 has the same units as whatever our x has, our random variable. And it's telling us right here, x is the number of times a newborn baby's crying wakes its mother after midnight. The expected value is the expected number of times per week a newborn baby's crying wakes its mother after midnight. So we would say that for the mean, 2.1 times the newborn wakes its mother after midnight is the expected value. Expected value is 2.1 times the newborn baby's crying wakes its mother after midnight. This same example asks us to calculate the standard deviation. So let's write down standard deviation. Standard deviation, we're going to give it the sigma, same as our population standard deviation. But our calculation for sigma is going to be different because, again, we don't have the data values. We have a probability distribution function. We are going to sum x minus mu squared times p of x and then take the square root of the whole thing. Again, let's do this on Excel. I'm going to grab my table. I'm going to Control C for copy. I'm on a PC. I think Command C is your Mac function, or just come up here and go edit, copy, paste. Okay? And so here I go pasting it. I have my expected value 2.1. We could do this a couple of different ways. Since our expected value is not going to change, we can hard code 2.1 in our formula. It's okay to do that. So on the column up top, I'm going to label this as x minus mu squared. We could do this like the book does it, in that it does this whole step all at once. X minus mu squared times p of x. It is up to you if you want to do it that way, if you want to do it all as one, or if you want to first find x minus mu squared and then multiply by p of x. You can do it in steps like that. I'm going to try it in steps to show you how you could do that. And then I can go back and show you how to do it all in one step. Decide which one is easier for you to understand. Okay. First step, x, I'm going to grab x minus mu 2.1 and then square it. Just like I have it in the table up there, we're going to do shift 6 for the caret and then 2 for squared. And we can hit enter and drag that on down all the way. And then over here in h, we're going to take the x minus mu squared. We've already calculated it. We don't have to calculate it again. Times p of x. Hit enter. When we do that, drag that down. And then we can calculate the sum of this column. 1.05. This would be our variance, by the way. But we're looking for standard deviation, so we would take the variance and square root it. SQRT is the square root function, and we can square root it. Everything I've done so far, you can replicate exactly the same way in Excel. So 1.02 would be our standard deviation for this problem. And sure enough, you can check, compared to the book, it does say 1.0247, so it is rounding those 6.9 up to 7. I honestly think the rounding rule of one more decimal place than your data, and in this case our data is our x values, still kind of holds, but be careful and make sure you're reading the homework problems to find out what they're rounding to. There are different rules out there, and I know that ambiguity can be frustrating too. But pay attention to what the instructions are and use the number of decimal places that they're asking you. If I back up and I look at just doing x minus mu squared times p of x, like I had said before, that you could do it all in one step. Instead of doing it right on top of what I just did though, I'm going to copy and scroll over a little bit, paste it. Let's clear these out and change this to times p of x. And now we'll do all in one step, x minus the mean 2.1 squared times p of x. And notice I'm clicking on the cells where x and p of x are so that I don't hard code them. Because if I do that, if I just click on the cells, then I can drag that down and you can see here I've got the same values showing up. And I should. I'm calculating it in a slightly different way, but I should still have the same values showing up because I'm trying to calculate the same thing. And sure enough, there's my variance because I have not taken a square root yet. SQRT on that number. Oops. Oh, it grabbed the wrong one. SQRT on L9 in my situation on that 1.5 gets me the same value for my standard deviation as it should. If you need multiple steps to calculate a complicated formula like the standard deviation, take them. You're allowing technology to work for you. So it's perfectly fine to break it into steps that make sense instead of trying to do it all at once. So notice both of these give us the same value.